Engineering applications of systems of linear equations static example. Engineering student is doing a statics problem and has arrived at these two questions from using the sum of the forces of the x equals 0, sum of the forces in the y direction equals 0. Those balance out. And we need to figure out what the tension in the cables T1 and T2 are. We've solved it a few different ways. Now we're at the point of solving it using Cramer's rule. So we set up our equations. Remember, Cramer's rule is an extension of solving it using matrix algebra. So we want to set up our matrices of A, X, and B. So there we see our three matrices come up. Remember, this is based on the form of A times X is going to equal B. So we have our coefficient matrix A. We just pull those values. We have our variable matrix X, and then our values matrix B. And if we multiply those back together, we get those same equations. And then if we have a quick aside about what Cramer's rule is, remember Cramer's rule, we use that we know that T inverse is going to be the absolute value of this special matrix A1 inverse over A, and T2 is going to be the determinant of this special matrix A2 over the determinant of A, where A1 is A with the first column replaced by B. So A1 is going to look like, instead of having these numbers here, it's going to have 0 and 95, but it's going to keep the 0.866 and the 0.500. A2 is the same thing. Column 2 is replaced. So A2 is going to look like negative 0.7071 for that part, positive 0.7071 for that part, and then over here on the right is where it gets in the second column. For A2, we get to 95. Okay, so that's how we get those things. So we have to get all these determinants. Remember, determinant of A, we take the coefficients this way and multiply them. So negative 0.7071 times 0.5, and subtract what we get when we multiply these two together. 0.866 times 0.7071. So the determinant of A is negative 0.7071 times 0.5 minus 0.866 times 0.7071, negative 0.9659. That's determinant A. We need to get determinant A1. So we're going to use A1 over here. Well, it's nice that it has a 0 in there. So 0 times 0.5 minus 0.866 times 95. A1, I'm going to ignore that first part, so a negative 0.866 times 95, negative 82.27. And if you have already solved this using matrix algebra, the previous one, you'll notice that some of these things start looking familiar. A2, we're going to find the determinant of this one, so it is negative 0.7071 times 95 minus 0 times 0.7071. So it is equal to negative 0.7071 times 95, negative 67.17. 45 if you keep the digits all the way out in your calculator. Okay, so we've got all the numbers we need there. We can go back to using these two equations. T1 is equal to determinant of A1, so it's negative 82.27 divided by A, determinant of A, which is negative 0.9659. So for T1, we get a value of negative 82.27 divided by negative 0.9659, 85.17 newtons for T1. And for T2, it's the determinant of A2, so it is, let's underline these so that we know those are the ones we had to pull. It's negative 67.17 divided by negative 0.9659. And so for T2, we get 69.55 newtons. So that's how we would solve that problem, almost fits on the one screen, using Cramer's rule. And again, as always, you can plug them back in and make sure those answers are right.